Okay, today we're learning synthetic division. First, let's be sure that we understand the long division that we have learned. It can be used to find the quotient of any polynomial and binomial. So this is kind of the catch-all. It may be long, but it works all the time. Synthetic division is our shortcut, but it doesn't always give the quotient. If our divisor has a coefficient of x that is greater than 1, it's not going to work. We can still get the remainder, but we will not be able to necessarily get the correct quotient. So we are only going to use synthetic division when the binomial or the divisor is in the form x minus c. So in other words, here's some examples. If it is x minus 4, we would use synthetic division. If it is 3x minus 4, we're going to use long division. Okay, so let's just be sure that we know when we should and shouldn't use synthetic division. So let's do this example and just teach ourselves exactly what synthetic division is. Now there are going to be 3 things that you need to pay attention to before you start the process. Okay, the first thing is we need to make sure that the dividend, which is this first one, it is in standard form. Now remember, standard form for a quadratic is ax squared plus bx plus c. So really all that means is that you've got your biggest exponent first and your smallest exponent last. That will put you in standard form. The second thing is we need to check for missing exponents, and if there are missing exponents, we are going to use a 0 as a placeholder. So let's look here. We've got a 4, 3, 2. Oh, we don't have a 2. So that means we're missing x squared. So we are going to put a little arrow here and a star so that we're sure that we include a 0 in the place of x squared. And then we have an x and then no variables. So that's the only one we're missing. And the third one is use the 0 of the divisor. Now, don't let this confuse you. Think about all the terminology we've been using. Here is my divisor. That is a binomial. Think of it as a factor. So if this is a factor, what is the 0 of that factor? Remember, we take the opposite of that number. So the 0 of that divisor would be -3. Okay, so with all that, let's go ahead and start our process. First thing you are going to do is put a little backwards half box like that, and you are going to put this 0 of the divisor here, so it's going to be -3. Then we are going to use the quotients of all of our terms. Okay, so I'm going to do 8, 31, 0, don't forget our placeholder down here, -72, and -27. Alright, we are going to skip some space and draw a line down here because we're going to be writing some numbers in here. Alright, so the first step is going to be to bring the first number down below the line. Then we are going to multiply the number in the box times the number underneath the line. So -3 times 8 is -24, and I write that above the line under the next number. Now, this is what's different between this and long division. We are not subtracting the number that we write down. We're just combining the numbers as they are. So I have a +31 and a -24. So 31 minus 24 is 7. And I put that below the line. Now I go back and I multiply the -3 and, oops, let me change where I put that, the 7. -3 and 7 is -21. So 0 minus 21 is a -21. Now I'm going to multiply again the -3 and the number under the line, which is -21. That gives me a +63. So again, looking at this -72 and +63, I am doing -72 plus 63, which gives me a -9. And then I'm going to do -3 times negative 9, which gives me a positive 27. And negative 27 plus 27 gives me a 0. Now, this last number here is always going to be your remainder. And I'm abbreviating that because I'm out of room. So since that remainder is 0, we get to ask ourselves, is this divisor a factor of our dividend? Yes, it is, because the remainder is 0. So the same thing is working here that worked in long division. Now, we are going to find f of negative 3 to check whether or not we've done this right. So remember, the dividend is always going to be f of x, so you're going to plug negative 3 into that, or go to your calculator to y1, or y1, and look on your table. When you do that, you do get f of negative 3 equals 0, which tells me that we have done it right because these two agree with each other. So let's do another example. Okay, so here's a new problem. We have 3 things we need to check for. Is it in standard form? So I'm looking at 3, 2, 1, and 0. Yes, it is in standard form. Second thing we need to check for, are we missing any exponents? Well, we just looked and saw 3, 2, 1, and 0, so no, we are not missing anything, so we do not need to put a placeholder because they're all there. And the last thing is, we need to take the 0 of the divisor, and looking over here, my divisor is x minus 3, so the 0 of that would be a positive 3. So let's go ahead and bring down our coefficients. Oh, that's a bad 0. Alright, so I have gotten these numbers from 1x cubed, 12x squared, 17x, and negative 30. So we're going to draw our line. We bring down our first number, and then we multiply. 3 times 1 is 3, and we write that here. 12 plus 3 is 15. We multiply the positive 3 and the 15, and we are given a 45. When we add those together, we get 62. And we multiply our 3 times our 62, and we get 186. And when we do negative 30 plus 186, we get 156. Now, we have numbers and we have a remainder, but where's our quotient? Okay, so we have these numbers down here. We're going to use them to write our quotient, but we have to pay attention to the fact that the dividend started with x cubed. So that means our quotient is going to start with x squared. So I'm going to bring these numbers down and do 1x squared plus 15x plus the constant 62 plus my remainder over my my divisor of x minus 3. So this variable, an exponent, is always going to be 1 less than what the dividend started with. Okay. Let's do another example. I know these are going fast, so be sure and hit pause if you need to stop and think about a step. Okay, so is it in standard form? We've got x to the 4th, x to the 3rd, x, and 8. It's going down, so yes, it's in standard. Are all of our exponents there? We've got a 4, a 3, a 2. No, we don't have a 2, so we need to plug a 0 in here in between these two. So let's go ahead. Our 0 of our divisor is going to be a negative 5. So I have a 3, a 17, a 0, 0 here, a negative 47, and a positive 8. Go ahead and move this up. So I'm bringing this down with a 3. Negative 5 times 3 is negative 15. 17 minus 15 is 2. Negative 5 times 2 is a negative 10. 0 minus 10 is negative 10. Negative 5 times negative 10 is a negative 50. Nope, it's a positive 50. Negative and a negative is a positive. So 47 plus 50 is a positive 3. Negative 5 times 3 is a negative 15. 8 minus 15 is a negative 7. So this is my remainder. I want to write my quotient. My first term up here was an x to the 4th, so my first term down here is going to be an x to the 3rd. So 3x cubed plus 2x squared minus 10x plus 3 minus my remainder over my divisor. And that is my quotient. Now, is this a factor of my dividend? No, because it has a remainder that is not equal to 0. Be sure we can always find, if we have done it correctly, by finding f of whatever we put in that little box. If it matches the remainder, then we've done it correctly. If it doesn't, then we have not done it correctly and we need to go find our error. The fact that this always matches the remainder has a name. We call this the remainder theorem. And all you need to know is if you are asked to prove whether something is a factor with the remainder theorem, you are going to do f of whatever that divisor is. And if you get 0, then it's a factor. If you do not get 0, then it is not. So that's something to keep in mind. This should be enough to do your homework. Let me know if you have questions.